Hello students, here let's start a preparation of the alcohols. We'll be learning in this lecture preparations of the alcohols. But before we learn a preparation or the chemical properties of the alcohols, phenols, or even for that matter aldehydes, ketone, carboxylic acid, I'll give you one flow chart which will help you lot in solving many examples. The flow chart is very simple. I'll write over here. This is primary alcohol. Okay, this is primary alcohol. If you oxidize this, if you do the oxidation of the primary alcohol, you get aldehyde. Okay, and if you do the oxidation of the aldehyde, if you do the oxidation of an aldehyde, you get carboxylic acid. You get a carboxylic acid. Holds true for this reduction. If you do the reduction of the carboxylic acid, you will get aldehyde, and if you do the reduction of the aldehyde, you will get a primary alcohol. The reverse is also true. Now let's take one example for this primary alcohol. How is the primary alcohol represented? CH2OH. This is the primary alcohol, OH connected to carbon. Further it is just connected to one carbon. Okay, this is getting converted to this CH3C double bond OH. Why this is an oxidation? If you see in this molecule there are oxygen is same, but here one hydrogen is removed, another hydrogen is removed. Two hydrogens are removed. Removal of the hydrogen is also oxidation, right? From here to here it is changing to this CH3 C double bond OH. Here this process is oxidation from here to here because one oxygen is added over here. Right? Now other thing is what if it is a secondary alcohol? If it is a secondary alcohol, if you oxidize secondary alcohol, oxidation, you get a ketone. Okay, you get a ketone. Further oxidation is possible, but generalize, if you want to generalize this concept, generally we remember only this much. Okay. So secondary alcohol, and if you reduce a ketone, you will get a secondary alcohol. Like for example, secondary alcohol is this. Secondary alcohol is this OH. You do the oxidation of this. This will get converted to ketone. Why this is a oxidation? You see, I have removed this hydrogen and that hydrogen double bond is there. So that's why this is a oxidation. And reduction of the ketone gives you a secondary alcohol. You know, this is secondary alcohol, OH connected to a carbon. This carbon is further connected to just two carbons. So this is a whole flow chart you should be always having in your mind. Okay. So whenever you learn any organic reactions, this flow chart will help you a lot. Always keep with you. Okay. Always remember, keep with you means don't write and take. Okay. Keep in your mind. You should be knowing this. Okay. Let's learn further preparations of the alcohols. So preparation of alcohol. What I'll do is I will write certain questions over here. So these are the questions, preparations of the alcohol questions. There are 5 questions which is posted in front of you. You can give a try to this. You can pause this video for some time and give a try. So question is a propene to propane to all, then propene to propane 1 all, ethanol to propane to all, butane to one or butanone to butane to all, and butanol to butane 1 all. Like how we'll sort this out? Okay, there are 3 important preparation methods. So I will categorize. This is hydration. This is hydration of alkene. This category is hydration of alkene. Okay. Then this category over here, this category is ethanol getting converted to propane to all. Okay. This is Grignard reagent. This is reaction of carbonyl with Grignard reagent. Okay, this reaction. And these two, ketone changing to secondary alcohol, this is reduction. This comes under the category of reduction of carbonyls, both reaction. down. Reduction of the aldehyde will give you primary alcohol. We have just learned now, right? Reduction of the ketone gives you secondary. Reduction of the aldehyde gives you primary alcohol. So carbonyl means what? Aldehyde and ketone, isn't it? So these are three important reactions. Now hydration reaction, there are two reactions. One is acid catalyzed hydration, one is acid catalyzed hydration. I'll write here acid catalyzed. I know it's becoming very small, but hope you will be able to read this. Acid catalyzed hydration, and next is hydroboration of oxidation, I mean. Okay, so hydration means what? Addition of water to the alkene. When you add H plus and OH minus, the alkene is getting converted to alcohol. Like acid catalyzed hydration. So acid catalyzed hydration gives secondary or tertiary alcohol, and this gives a primary alcohol. Remember these things. Okay, reagents you should be aware. So first we'll discuss with these two reactions. First I'll discuss with those two reactions. First two. So propane to propane to all. Propane. This is propane. I'm doing first one A. Propane to propane to all, I mean, yeah. Propane to all. Like this is a addition of water to the alcohol. This is, you'll write H2O and H plus. H plus represent acid. You can write HCl, H2SO4, all these things over here. In exam also it may be written H2O, and instead of writing H plus, they may write H2SO4, HCl, HNO3, this kind of thing. Means you have to understand that it is acid catalyzed hydration. Hydration means what? OH minus is added over here and H plus is added over here, right? So this OH is getting connected over here, this CH2 is getting converted to CH3 and double bond goes. That is what the hydration. And this reaction is acid catalyzed hydration. Second is what? Propane to propane 1 all. Propane to propane 1 all means you need to convert this propane to propane 1 all. Propane 1 all means what? OH is over here. This is propane 1 all. Means this is a primary alcohol. This is primary alcohol. This is propane 1 all. And this is secondary alcohol. This is propane 2 all. Right? So what are the things? Acid catalyzed hydration, if you are doing, you will get this product. We don't want that. So we'll use a hydroboration oxidation. I will write HBO, hydroboration oxidation. What are the reagents for that? It is B2H6, or it is also written BH3, H2O2 in presence of base. So these are the reagents for that, and that will give you a primary alcohol. Done. These two reactions are done. So next is ethanol to propane to all. Ethanol to propane to all. So this is with a Grignard reagent. Reaction of the carbonyl means I am doing C. This is reaction of ethanol with Grignard reagent. Okay, so I am writing over here C. So ethanol is what? CH3, C double bond OH. Now for simplicity we'll write it this way. C double bond, like I'll give you the trick how to do this. In whole of the reaction, this and this bond will remain intact. That is not going to change. You don't have to change that. Only the reaction will happen over here. Right? I'll write. Grignard reagent is what we want. Propane 1 all means already there are 2 carbons in a system. I want 1 more carbon. So I will take methyl magnesium bromide. This is my Grignard reagent. So after a reaction with this, what do you get is CH3, yeah, this I am keeping intact. Both the things I am keeping intact. So this is O, Mg, Br, and methyl is connected over here. Right? This is partially negative. partially negative, partially positive, partially negative, right? So methyl is added over here. After hydrolysis means it is written H2O and a H plus, or H3O plus could be also written. Means you have to understand hydrolysis, not hydration. Understand the difference between a hydrolysis and hydration. Hydrolysis is breaking of bonds using water, and hydration is addition of water, right? This is what I have done in the previously. It was addition of water. So what do you get over here? This is CH3, H, CH3, OH, right? Plus Mg, OH, Br as the byproduct, but this is our main product. So what I am getting? This is a parent chain, 1, 2, 3. So this name is propane to all. This is the name of the compound. Then butane 2 on to butane to all. Butane 2 all to butane to all. This both the reactions are reduction reaction. Means it is ketone, butane 2 on I can write this way, or butanone also fine, because there is only one possibility, here or here. It will be always butanone. Okay. Now reducing agent, you should be knowing about the reducing agent. Which are the reducing agent? Reducing agent, you should remember. I'll claim this and write over here. So these reactions are done. Reducing agents. So you know this hydrogen in the presence of platinum, palladium or nickel. This is a good reducing agent. Lithium, aluminium hydride. This is also a very good reducing agent. Third reducing agent is NaBH4. This is a very good reducing agent. Then sodium in the presence of C2H5OH, ethanol. This is also a very good reducing agent. You can use any of this. Means you use hydrogen gas in the presence of platinum or palladium or nickel. This or NaBH4 or lithium aluminium hydride or sodium and ethanol. You use this, like this is win-win situation for you. You know the reduction, you know that process is identifying the process, what is happening in the reaction, reduction or the oxidation. Once you get that particular reaction is reduction, you have to just remember a reducing agent. You know this reducing agent, you can add any one of this, you are winning both, because it is from ketone to, if you do the ketone reduction of this ketone, you will get a secondary alcohol, that is this, right? You will get this. So that is what we want, butane to all. This is butane to all. Butane to all, a secondary alcohol, right? Again, next is butanol to butane 1 all. Butanol means what? Butanol is this way, C double bond OH. And you use same reagents, whatever is there on the top. Use this or this. Doesn't matter. Any of this reducing agent. This will change to what? CH3, CH2, 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 OH. Right? So butane 1 all. This is 1, 2, 3 and 4. The naming is butane 1 all. Right? So these are the preparation. This is how you do the organic reactions. You have to categorize, all this reaction. Whether it is reduction, oxidation, okay. Hydration means what happens when we add water to the alkene, all these things. So this can solve, it will give you the flexibility in a reaction. That is what is very important for the boards as well as for the competitive exams. Okay. So we'll go ahead with this. This question, convert benzyl chloride to benzyl alcohol. Now, what is benzyl chloride, right? So, benzyl chloride is this. You take a benzene, and don't add chlorine over here. This is benzyl. Like chlorine is connected to sp3 carbon next to it, not directly. This is benzyl chloride. This is benzyl chloride. You need to convert this to what? Benzyl alcohol. Benzyl alcohol is this CH2OH. How you will do this? Right? This is benzyl alcohol. This is just a substitution reaction. Do you remember haloalkane, haloarine, SN1 and SN2? The haloalkanes were getting converted to what? Alcohols. There we were learning that reaction is what? A chemical properties of the alkyl halide. Here same reaction we are learning as what? Preparation of the alcohol. Right? There also the product was same. Here also the product is same. But only the way we look at the reaction is different. There we were learning that is the chemical properties, how alkyl halide is going to react with a base, that is nucleophile OH minus. Here same reaction we are learning as a preparation method. So what you will do, you just put NaOH, no? NaOH, aqueous. If this Cl was over here on this carbon, it is very difficult to substitute. Remember this, chlorobenzene, right? Chlorine is connected over here, it is chlorobenzene. That is very difficult to substitute. Right? So, it is connected to what? sp3 carbon. It is same as SN1 or SN2. So, this is what the compound, this is what the reaction you are going to write. This reaction, convert methyl magnesium bromide to 2-methyl propane-2-ol, means methyl magnesium bromide to 2-methyl propane-2-ol. How you will write this? Carbon, propane, no? 3 carbons. On second position there is alcohol, and on second position there is methyl. So this is tertiary alcohol. When do we get a tertiary alcohol from a Grignard reagent? It should be a ketone. Always remember, when it is a formaldehyde, remember this, formaldehyde plus Grignard reagent, it gives primary alcohol, because this is the only alcohol, formaldehyde is the only one which will give a primary alcohol. Okay. Then remember, then aldehyde plus Grignard reagent gives you secondary alcohol. And ketone plus Grignard reagent gives you what? Tertiary alcohol. You can remember this. Okay, we want tertiary alcohol. So what I should react with this? I should be reacting with a ketone. Now you see that there are 3 carbons, right? There are 3 carbons and one is getting attached. That is from the methyl. So what ketone it should be? It should be acetone. CH3, C double bond CH3, C double bond O. Right? So you will get this methyl magnesium bromide after, zinc, or what we write is a Zn and H3O plus, means hydrolysis. After hydrolysis, final step I have written, means this reaction will go in this manner: CH3, C, CH3, O and Mg, Br. This is reacting with the Grignard reagent. See, again these 2 groups are remaining intact. This is changing to OMG, Br, and this methyl is from where? Grignard reagent. Further, if you do the hydrolysis, what do you get? CH3, 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 OH plus Mg, OH, Br. That's it. So I have covered maximum very important reaction in this revision session. Just focus on this. It will help lot in both the exams, competitive as well as your boards, especially Goa board students. Thank you.